We're now going to look at the slightly more complicated way of calculating the resultant of adding two sine waves, and if you wanted to, subtracting one sine wave from another. And we're going to go with the same example that we were working with for the graphical. So with the graphical we had a normal voltage, 30 volts AC, okay, with no phase shift, and then added to that we had 40 volts AC, and that was phase shifted by 30 degrees. And we used a resolution of forces to work out the resultant and its angle. The resultant of adding V1 plus V2. And I'm going to show you a different method, which is the resolution of forces method. So in order to do that, we have to be aware that any vector or any force which has a magnitude and direction can be resolved into horizontal and vertical components. And we're going to do that with these two voltages here. What I tend to do is draw a table. H stands for horizontal components, V stands for vertical, like that. And then I take each voltage in turn. So this will be my first voltage, and this will be the second. So starting with this one, 30 volts AC, there's no phase shift associated with it. It's completely horizontal, so it has no vertical component. So we can write 30 volts in this column. And then we go to the second voltage, and I'm just going to draw that one down here, just for clarity's sake. This voltage will have a horizontal component, and it will also have a vertical component. So to resolve those two, we can use trigonometry, and the horizontal can be found, this component can be found by using the adjacent, this is the adjacent here, over the hypotenuse is equal to the cosine of this angle. Now we know this angle is 30 degrees. So with a little bit of rearrangement magic, we take the hypotenuse over here, we know that's 40, so to find this horizontal component, A, is equal to 40, that's the magnitude of the hypotenuse, times the cosine of 30 degrees. And I did, like a cook, I did that one earlier actually, just to save a bit of time, and that comes to about 34 volts like that. So I draw that into my horizontal components table. The vertical component can be found in exactly the same way using trig again. This time we have to use the other identity, the opposite over the hypotenuse is equal to the sine of 30. So this vertical component, the opposite to this angle, which is 30 degrees, this is the hypotenuse. When we do our little bit of a magical rearrangement, we get the opposite is equal to the hypotenuse, which is 40, times the sine of 30 degrees. Now on your calculator that's going to be 0.5, so even I know that 0.5 times 40 would give me 20, like that. Okay? And therefore to find the magnitude here, there's various ways of doing this, but let's just go with an obvious one. To find the magnitude of the resultant, we can use Pythagoras. Yes, you bet you wondered when you're going to use that in school. Well, here you are. So if I was to take my horizontal components here, we've got 30 and 34, and I draw those horizontally like this. Okay, so you imagine this one here is 64. The vertical I'm going to draw up there like that. Okay, and that's going to be 20. And my hypotenuse can be found, of course, by a squared plus b squared. So we've got 64 squared plus 20 squared is equal to c squared. Okay, so it's basically you get the square root of these two is equal to the hypotenuse. The phase angle, we can use the tangent. So we know that the tangent is equal to the opposite over the adjacent. So the tangent at that angle there is going to be 20 over 64. And when you inverse that on your calculator, tan minus 1 or arctan, that will give you this phase angle, and that's how you work out the resultant magnitude and phase angle for adding two sine waves together. In the case of V1 minus V2, so let's have a look here. This is V1. V2 would be drawn in this direction. The only thing you've really got to be aware of is that the vertical component will be a minus, and so will the horizontal. Okay, so you need to be aware of that. So for example, imagine that when I resolve this, this becomes 34. Actually, it becomes minus 34. So your horizontal component would be 30 minus 34. Yeah? And the vertical would be minus 20. But apart from that, it's exactly the same technique. Anyway, hope it helped.